Good evening, Moksha. नहीं मेरे पैर में ही कर रहा हूँ.
Good evening.
Yeah, good evening. Good evening, Abhinav. चल. M-Metals.
Good evening, sir.
Yeah, good evening. Why the first line? So in the last class, we were doing about metals. All right. So we had done the extraction of metals, and in that we had learned the three processes of extracting. So Shubhansh, what were the three processes of extraction of metals?
Hello. Yes, sir. You
Yeah.
saying?
Shubhansh, what were the three methods for extraction of metals?
Sir, three process of metal extraction.
Yeah. How did we try to extract the metal?
Sir, I don't remember the name properly, but it was using water, using heat, and electricity.
Using water, using heat, using electricity. Okay, so you remember just a little bit about it. See, we remember that first we divide the metals under three categories. All right.
Yes. Yes, sir.
So we divide the metals under three categories: highly reactive, less reactive, medium reactive, and least reactive. All right. Those which are of highly reactive, they are separated by the method of electrolysis. Okay. Those which are of low reactivity, they are found in their native state, or they can just be obtained by roasting. Okay. So we can use the roasting method to obtain the metal, or the last was reduction. So you reduce the metal, and by reducing the metal, first you have to obtain its oxide. Okay. And to obtain the oxide of the metal, we perform two processes which are called as calcination and roasting. So see, if you remember the table was something like this. You had a high reactive metals. Okay. Then you have medium reactivity metals. You have medium reactivity, and you have low reactivity. So high reactivity, medium reactivity, and low reactivity. Medium reactivity means the metals which are of a medium reactive. Highly reactive, they are obtained by the electrolysis. They are obtained by the electrolysis process. The low reactive metals, they are either occur in their native state, or they can be obtained by roasting. If a few of them are occur in the form combined, so they can also be obtained by the roasting process. To obtain the metal directly, they obtain the metals. And those in the medium reactivity, So first of all, if there are carbonate ores, so for the carbonate ores, we have the process of calcination. For the carbonate ores, we have the calcination process, and for the sulfide ores, we have the roasting process. So for the sulfide ores, you have the roasting, and for the carbonate ores, you have the calcination. So in the calcination method, it was just so for the carbonate ores, we just heat them. Okay, with that there is no requirement of oxygen. I'll just describe the calcination process. And in this roasting process, they are heated in presence of oxygen. After this, what is the output of this? So the output of this you obtained as the metal oxide. Okay. So here you obtain the metal oxide. The metal oxide can be further reduced. So, okay. So metal oxide, it can be reduced by carbon. It can be reduced by carbon, right? So it can be reduced by carbon to obtain the metal. Got it? So these were the three things which we had done. For the low reactive metals, you can think of the aluminum sulfide. Okay. So just like the aluminum sulfide, so not aluminum, mercury sulfide. We discuss here mercury sulfide, HGS. Okay. So as you can see, mercury, it lies in the series with the low reactive metals. All right. So it is a low reactive metal. We can just perform its roasting, that means heating in presence of oxygen, to obtain our mercury and sulfur dioxide. So what process we have done here? The name of the process? Can anyone tell the name of the process?
Redox.
No, this process is roasting. Okay. So roasting means, it means heating the ore in the presence of oxygen. This is called as roasting. Then, so this process can be used for a number of sulfide ores. Whereas if you are using this process for low reactive metals, you will directly get the ore. You will directly get the metal. Okay. For example, even if you can do it for copper also, for copper glance, you can use copper glance or CuS, copper sulfide. When heated in presence of oxygen, it gives us copper plus sulfur dioxide. Got it? Now we see for medium reactivity series. So for medium reactivity, we have studied both the processes. What are the two processes for the medium reactive metals?
Roasting, calcination.
Yes. So for the medium reactive, we use the process of roasting and calcination. So for which, what is calcination? Let's see. I told you what is roasting. So let's see what is calcination. So calcination, it is the process of heating the ore in the absence of, it is a process of heating the ore in the absence of oxygen. If you heat the ore in the absence of oxygen, that we call as the calcination. All right. So for which ores it is done? It is done mainly for carbonate ores. For example, if you have zinc carbonate, okay. So let's see zinc carbonate, and here what process will perform for this? We'll use calcination. So when we use calcination for this, we obtain zinc oxide and carbon dioxide. We obtain here zinc oxide and carbon dioxide. Similarly, if I use, if suppose I have zinc sulfide, okay. So zinc sulfide, this is not a carbonate ore. So this has to be heated in presence of oxygen. So what product do you expect here? So for this, we are performing here roasting. This is not calcination. We are performing roasting. So what product do you expect here?
Zn plus SO2.
Which one?
Zn plus
Zn plus SO2. Yeah, that is what we expect. But this is not the product which we obtain here. Okay. The reaction, this you need to care. That's why just look at the table. I have told you that after calcination and roasting, you will be getting the oxide of the metal. So here you will be getting ZnO, zinc oxide plus sulfur oxide, SO. Okay. Now see SO, which is formed here, it reacts with more amount of zinc. So ZnO, it reacts with more amount of sulfur oxide to form again Zn. So it reacts. You get here sulfur dioxide. Just balance this reaction, and this ZnS plus O2. Okay. So this is the reaction that takes place. You obtain zinc oxide. Okay. So this is calcination and roasting. You obtain. Now you obtained your zinc oxide. So this zinc oxide can be reduced by the help of carbon. So this is the middle step which we are doing here. This step. Carbonate ores, they are performed as calcination. Sulfide ores, they are roasted. So you obtain your metal oxide here. So here you obtained your metal oxide, that is you obtained your zinc oxide. If you use your irons, you got your iron oxide, Fe2O3. Right. So this iron oxide or zinc oxide, now these metal oxides which we have obtained at the third step, they can be performed or they can be reduced using carbon. So you have to perform reduction.
Excuse me, sir.
Yes.
Sir, can you once again explain calcination?
Okay, just 1 minute. Calcination is just heating the metal in the heating the ore in the absence of oxygen. Okay. And this calcination process, it is done only for the carbonate ore. It is not done for all the other. So if there is any carbonate ore, like you have zinc carbonate, you have calcium carbonate, so you can perform its calcination. Got it? So zinc carbonate, it can be heated. Calcination is the process of just heating it. Okay, this is the process of heating it. All right. So is it understood?
Yes, sir.
Of heating. By the process of heating, you obtain zinc oxide and carbon dioxide over here. So if it is a sulfide ore, then you just heat it in presence of oxygen, you get zinc oxide and sulfur dioxide. Once you have obtained the oxide of the metal, so at this stage you see you have obtained the oxide of the metal. So reducing using carbon, you can use your zinc oxide will react with carbon that is heated into so zinc oxide plus carbon, when heated, it will give you zinc plus carbon monoxide. Okay, and this carbon monoxide which is obtained here, it can be further used. It is not allowed to skip here. So zinc oxide reacts with further with carbon monoxide, again heated, so to obtain still zinc, and now it is obtained as carbon dioxide. So this carbon dioxide is allowed to move out of the heating chamber. Understood, everyone?
Sir, is carbon monoxide used for anything?
Yeah, this carbon oxide is not being allowed to escape out of the reaction chamber.
No, sir.
Okay.
Not in this reaction. In the normal.
Yeah, in the normal, carbon dioxide has a number of uses.
Ma'am,
It is used in,
sir,
yes,
carbon monoxide.
yeah, carbon monoxide only. It is used in the manufacturing of some chemicals like some methane, or in the manufacturing of what we call hydrogen. All right. So in the manufacture of alkanes, we use carbon monoxide. Yes.
Yes, sir.
Anything else? Anything else?
No, sir.
Okay. So I hope everyone is able to recall what we studied in metals and non-metals. How about the extraction of metals? Everyone has understood now. Okay. So if you have Fe2O3, how will you extract this? How will you obtain iron from it? How do you obtain iron after you obtained Fe2O3? So you heat this Fe2O3 in presence with carbon. You get here Fe plus carbon monoxide. Again the same way. Okay. So this carbon monoxide again reacts further with this Fe2O3 to give you Fe. You just need to balance this reaction. You write here 2, and here you write, you will be getting 4 Fe. So you get here amount of oxygen that you get is 6. So you write here 6 CO, and this will be 6 carbon. So now the reaction is balanced. Now this carbon monoxide again is utilized further to reduce iron oxide to obtain carbon dioxide and iron. Got it, everyone? Yes, I think everyone has understood how to obtain the how to perform the extraction of the metal.
Yes.
So see, now again I'm giving a quick revision of how do we extract the metals. So when you extract the first, what do you get from the earth? That is the ore. Okay. So what is an ore first? Ore is it is a mineral obtained from Earth's crust. Okay, so ore, it is a mineral obtained from the Earth's crust. So definitely it has a number of impurities, like it has the sand particles and a number of other things which are mixed with together. So then we call as the gangue. So what is the gangue? It is the impurities present in the ore. Then how do we separate them? So that process is called as enrichment. Enrichment of ore. So what is enrichment of ore? It is the process of separating gangue particles. Okay. So once we have separated the gangue particles from the ore, I talked of you with different methods like with hydraulic washing, and there are other methods with which you can perform the enrichment of the ore. This process is also called as the concentration of the ore. So enrichment of the ore, or you can also call it as concentration, as you are increasing the concentration of. This is also called concentration or enrichment of ore. Okay. So in this process, what you are doing, you are just removing the gangue particles. So once you have removed the gangue particles, our next step after that starts. So after this, we start with, once we have obtained the ore, so then we look whether it is a reactive, a highly reactive, less reactive, or low reactive. All right. So if it is a high reactive, we go for electrolysis process. Electrolysis, which is used generally for separating aluminium. Okay. So generally for separating aluminium, we use the process of electrolysis. So this is a high reactive, that is ores for aluminium, which can be like Al2O3 or any other ores of high reactive metals, even calcium oxide. For the medium reactivity, so for the medium reactive, we had learned the process of reduction using carbon. So reduction using carbon we can do only for oxide ore. So first we obtain the metal oxide. Okay. Once we obtain the metal oxide, then we perform its reduction using carbon to obtain the pure metal. Okay. So sometimes you may directly, after the enrichment of the ore, you may directly get the metal oxide. Sometimes you may have a carbonate ore or a sulfide ore. So you perform its calcination. So if the ore is a carbonate ore, then you perform its calcination. If it is a sulfide ore, so then you perform its roasting. Understood, everyone? So for the carbonate ores, you have the process of calcination. For the sulfide ores, you have the process of roasting. Okay. Got it, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So after the calcination and roasting, you obtain the metal oxide. Once you obtain the metal oxide, you proceed it. So for the low reactive, you directly go for the roasting process and you obtain your metal. Okay. So just I will see according to the book what all different things are given. So see the same process described over here. At the last, once you obtain the metal, then you can perform the purification of the metal. So the last process, you will be using electricity, but this method is just the purification. Okay, purification. That means you have obtained the metal, but still it may contain some of the impurities. All right. So we need to purify it. We purify it by the purification of the metal, which may involve electrolytic refining. All right. So what are the questions expected from this? So the most probable questions which have been asked from this topic, they are questions from extraction. So I think everyone should pay attention now. Now we are looking for the questions which come from extraction. The questions which we obtain from extraction, you have define, calcination and roasting. So these are the things you should be taking care with. You have to define calcination and roasting with reactions or with examples, you can say. Then you have to define food, then mineral, okay, so ore, mineral, and you may have questions related to electrolytic refining of copper. So, however, there are very less questions related with electrolytic refining of copper. One more thing, yeah, this definition is also asked. The last one is enrichment. Then you have the next one as after the enrichment process, you have this one. Just 1 minute, let me recall the definition. Can. So these are some of the questions which may be asked from this extraction of metals. Remember, we haven't still done electrolytic refining of copper. I'll just check the syllabus if it is there. Earlier it was there, but now I need to check whether it's there or not. So see, the metals which are low in the reactivity series, you are taking mercury sulfide, you are heating this in presence of oxygen. So what is the process? What we are performing here with mercury oxide and with copper sulfide? Which process are we doing? Yes, what is the process that is being done to this? What is the name of the process?
Calcination.
Yes. Just name this process. Who will name this process? The process which we are performing with mercury sulfide and copper sulfide.
Reduce using carbon.
Are we using carbon here? Is there anywhere we are using carbon?
No, sir.
No. Just tell what substance we are using here. Yes, what substance we are using?
Copper sulfide.
No, copper sulfide, that is the ore. Okay, copper sulfide is the ore here. Copper oxide is the ore here. Mercury sulfide is the ore. Okay. So what process we are using here? The process we call it. The process we call it as roasting. Just we learn roasting. So what is roasting?
Heating the ore in the presence of
Heating the
oxygen.
ore in the absence, in the presence of
Oxygen.
oxygen. So are we doing the same thing here?
Yes, sir.
Well, so just be clear with your formula, with your definition. All right. So this we are doing roasting for the low reactive metal. Mercury and copper, they are low reactive metal. Now see the in the middle of the reactivity series, you have zinc sulfide. So for zinc sulfide, you are performing roasting, and for zinc carbonate, you are performing calcination. That means you are heating the carbonate out only. No oxygen is required. Whereas if you have a zinc sulfide, so you are heating it in presence of oxygen. Got it?
Yes, sir.
So see, these are the same things which we have done in the form of a chart, which will be very easy to remember. Okay, in the form of chart, you can remember them easily. Okay. So any doubts here?
No, sir.
Okay. Now the last process. Can you see here any reaction of reduction using carbon? Yes. Is there any reaction of reduction using carbon? See, the zinc oxide which we obtained in by the calcination and roasting.
Yes,
We
sir.
obtained here zinc oxide during the process of calcination and roasting. Here, this is the zinc oxide which we obtained during roasting. This is the zinc oxide which we obtained during calcination. So this zinc oxide is being reduced using carbon. It is being heated using carbon to obtain zinc sulfide, zinc and carbon monoxide gas. So this carbon monoxide gas is not allowed to escape. It is further reduced. All right. So see. Okay, that reaction is not written here. Okay. Now for obtaining sodium, calcium, and aluminum, they are high reactive metals. So which method do we use? Yes, Sumuk. Which method should be used for them? Sumuk, which method do we use for them?
Sir, electrolysis.
Yeah, electrolysis method. Okay. So for them, we use electrolysis method. Sometimes we also use displacement reaction for obtaining the metals in the middle of the reactivity series. For example, to obtain iron from iron oxide, uh, we use a displacement reaction with aluminum, the bottom reaction which you see, the reaction at the bottommost position. You see, you have iron oxide See this one. This reaction, you have iron oxide. This is the ore also, Fe2O3. If you react this with aluminium, so there is a displacement reaction. The oxygen is getting displaced, or you can say the iron will get displaced from its position by aluminium. All right. Out of iron and aluminium, which one is a more reactive?
Iron.
Yeah, iron is more reactive or aluminium? Check your reactivity series. It's aluminium is more reactive. So aluminium is going to displace iron from its position, and hence you will have your Al2O3 plus 2Fe. Okay. The amount of heat that is produced, this is highly exothermic reaction, and the amount of heat produced is so large that iron produced here is obtained in the liquid state. You obtain your iron in the liquid state. Okay, and this reaction has a special name. Can anyone remember the name of this reaction?
Thermit.
Yeah, it's a thermit reaction. Okay, so it's thermit reaction which is used during the the name of this reaction is a thermit reaction. Yeah, so this question is also very important from this thermite reaction. Thermite reaction. This is the example of thermite reaction where we have the displacement of a low reactive metal by a high reactive metal from its oxide, evolving a large amount of heat. Okay, so this reaction is used in the process of, or you can say that this reaction is used for welding of railway tracks. Since you obtain your iron in the molten state, it can be used for welding of the railway tracks. So wherever you have cracked railway tracks, that can be welded using this. So see this worker performing this reaction over here. So this worker performing the reaction of a thermite reaction. He is welding the railway tracks. Yes, anything?
No, sir.
Okay. So I think everyone is clear with this, and you have also understood what to learn from this topic. All right. Now only one topic is left, that is refining of the metals. So this electrolytic refining, I'll just check the syllabus if it's there. We'll do this, and corrosion, of course. I think corrosion is also not there.
We have.
We have, okay, so we'll do corrosion and electrolytic refining. With that, the chapter will be over. All right. Bye, everyone. See you again in next
Thank you,
class.
sir. Bye, sir. Have
Bye, sir.
Okay, bye. Hmm?